Hello everyone. Am I audible?
Yes, sir. Good evening.
Am I audible?
Yes, sir.
No, I am not able to hear you. Give me a second. All right, give me a second. All right, can you try seeing something?
Yes, sir. You're audible.
No, still not able to hear you. Give me a minute. All right. Am I audible now? Everyone?
Yes, sir.
All right. How's everything? Ronaldo, Krishna, Susum.
Yes,
Good
sir.
evening, sir.
It's fine.
Good evening. Any doubts from the last classes?
No, sir.
All right. So let's start today's class. Let's start with the question. If A is equals to cos alpha sin alpha minus sin alpha cos alpha such that A transpose is equals to A inverse. Find alpha. All right, very easy question. Let's solve this one. I hope you remember how to find A inverse. And let me give you a small hint. One way to solve this question is to find A transpose, then A inverse, and A square. Right? The other way to do is let's multiply A on both sides. All right. So this becomes A transpose A is equals to A inverse A. Now, Krishna, what is this A inverse A?
I.
I. So this becomes A transpose times A is equals to I. This way, you can solve this question. Because this is easiest to multiply A transpose times A is easier than finding A transpose and A inverse, right? So you can use this way also. Multiply this to compare that with identity matrix. All right. Can you solve this? Kulsum, Krishna, Ronaldo.
So when I'm solving, I'm getting the identity matrix itself.
Yes, you will be getting identity matrix. How to find alpha? You have to compare. Right? This must be equal to this. So you have to find the value of alpha. Let me solve. All right. Also, what about you?
Even I got the identity matrix. I did it till then.
Right, right. So can you tell me what you're getting on the left side, or should I solve this?
So cos 1 cos square plus sine square alpha, then sine alpha cos alpha minus sine alpha cos alpha.
Cos alpha, sin alpha minus.
Sin alpha, cos alpha.
All right, and here
Sin alpha, cos alpha minus cos alpha, sin alpha.
all right, here
Sin square alpha plus cos square alpha.
all right, and we know this must be equals to identity matrix that is 1001, right?
Yes.
Because this is our this is the additive side and this is the RHS side. So on this we know that this becomes 1, this becomes 0, this becomes 0, this becomes 1. So yeah, that absolutely right. We both are getting identity matrix. That means no matter what you put instead of alpha, always get identity matrix,
Yes.
right? This means only that no matter what you put instead of alpha, what you will get identity matrix. That means this solution of alpha here is all real values. All real values of alpha satisfy the given equation. Is this clear to everyone?
Yes, sir.
Yes, sir.
All right. Let's try another question. Find the matrix A such that determinant A is 2 and adjoint of A is equal to 220 251 All right. How to solve this type of question? They are asking you to find a matrix whose determinant is 2 and adjoint is this, right? Until now, they have solved the reverse question. They gave you a matrix and asked you about adjoint or determinant. So how we can do this? We know that A times adjoint of A is what? Anyone can tell me the formula or property? A times adjoint of A. Just now. Also,
A times adjoint of A is AI.
determinant A.
Yeah, determinant AI.
Right? Absolutely right. So from here we can say multiplying adjoint of A inverse on both sides. Right? What will get? A times adjoint of A times adjoint of A inverse is equal to determinant A I adjoint of A times inverse. This step is clear, everyone?
Yes, sir.
Yes, sir.
So this becomes what?
I.
I. So A times I becomes A matrix. And this is determinant A and I times adjoint of A inverse is adjoint of A inverse only. So we can find A matrix like this. Right? Determinant A is given. Find adjoint of A inverse because you know adjoint of A matrix is given. So you can find inverse of that. Multiply both, you will get A matrix. Is this step clear?
Yes, sir.
All right, Kulsum, this is clear.
Yes, sir.
All right, Ronaldo.
Yes.
All right, then solve it. Find A matrix. Write down the question and the steps, then solve it. Hello, Shikani. You are late today. Shikani, are you there? Guess not. Solve this, everyone. Krishna, solve this.
Just a minute, sir.
All right.
Done, sir.
All right. No doubts, Kusum?
No, sir.
All right. All right. Everyone, tell me when you are done solving.
Can you tell me the answer of the previous one, sir?
So I don't have the answer. We can match all the answers, all of your answers. Or if you want, I can solve this.
Then can you show it once, please?
Sorry.
Can you show it once?
All right. Let's try to match the answers first. Or I will say I'm trying to finish this chapter today. So just first check if all of the answers match. Also, can you tell me your answer?
2 minus 1, 1.
All right.
Minus 1, 1 minus 1.
All right.
1 minus 1, 3.
Krishna, does your answer match?
Yes, sir.
All right. And Ronaldo, what about you?
Yes, sir. So,
All right. So, Kusum, do you need me to solve this or shall we move ahead?
We can move ahead. Thank you, sir.
All right. Actually, I'm trying to finish this chapter today, right? So that we can move ahead with the syllabus. So there are few properties of inverse. Like few of the properties. First property I've already told you. Let's solve one question that AB inverses. Anyone remembers this?
A in B inverse.
A inverse, A inverse.
Right, B inverse and A inverse. All right, if you multiply two matrices and then take inverse, that would be equals to the order will change. B inverse multiplied by A inverse. All right, we know that in matrix multiplication, order is very important. A inverse and inverse. Inverse of A inverse. What would this become?
A.
A. Absolutely right. A transpose inverse. would be equals to A inverse transpose. All right.
Yes, sir.
All right. Note it down, everyone. Right. Note down firstly and tell me when you are done. Well done. Firstly.
Yes, sir.
All right. Next is one of the most important. You can get MCQ question in this. If you find adjoint of A determinant, then this becomes determinant A to the power n minus 1 square. If you remember adjoint of A determinant, what is the answer here? Determinant of adjoint of A. Does anyone remember this? Kulsum, Krishna, Ronaldo.
Sir, is it a determinant of A power n minus 1?
N minus 1, right? This is also very important. Don't forget this properties. Right? We know that determinant of adjoint of A is determinant A to the power n minus 1. If you take n1, then find determinant, then this power becomes square. Alright, very important. This is very easy. Adjoint of A transpose is equals to adjoint of A full transpose. Alright. The last one is also very easy. No proof is not needed. Just knowing these properties works fine. Alright, write down all the properties. Anyone has any doubt on these properties? Kulsum, Krishna, Shikani, Ronaldo.
No, sir.
All right. Done.
Done, sir.
So theoretical part is over. Last part is remaining. Application of determinants and matrices. How to apply these in questions. All right. The first is, before that, let me ask you, does anyone know what is consistent systems? If I give you two equations, 3x plus 4y is equals to 5, 4x plus 5y is equals to 6. What does it mean to be consistent? Does anyone know this?
Sir, having a solution.
Having a solution. All right. And what does it mean to be inconsistent?
Sir, no solution.
No solutions. All right. So to sum it up, these are the equations of a straight line. This we all know, right?
Yes, sir.
So two given straight lines can have three types of situations. First is having unique solution. Right? They both intersect at one single point. The second situation can be where they coincide. One lies on top of other many solutions or infinite solution. The third situation can be that both lines are parallel solution. Like this we all know from class 10, I guess. Right?
Yes, sir.
These first two situations are called consistent. The last case is inconsistent. All right, so you can write it down. A system of linear equations is said to be consistent if it has solution one or more, and inconsistent if it has no solution. Right? You write a complete sentence. I can skip. I am the teacher. All right. This is cool, everyone. No doubts here.
No, sir.
All right. Write it down. Tell me when you're done.
Done, sir.
All right. Now coming to something new of last week. The solution of system of linear equations using inverse of a matrix. All right. We are going to solve a system of linear equations using matrices. Right. We have three linear equations. When all see that, right, with different coefficients. How to solve these using matrices? Normally we can solve, right, elimination method, substitution method. We all know that. But how you can do this using matrices? So let's suppose we have a matrix A with all the coefficients of x, y, and z. But A1, B1, C1, B2, B2, C2, E3, E3, and C3. All right. And the matrix X with X, Y, and Z. And the matrix B with the coefficients of constants B1, B2, and B3. All right. We assume these three matrices. Can anyone solve and tell me what we will get by multiplying A with X? Multiply A with X and tell me what you are getting.
Sir, A1x plus B1y plus C1z and A2x plus B2y plus C2z and A3x plus B3y plus C3z.
All right, everyone is getting this answer full sum. Also, Ronaldo, are you getting this answer?
Yes, sir.
Right, because A1 times x, so A1x plus B1y plus C1z, right? This is 3 by 3 matrix, and this is 3 by 1 matrix. So the final answer will be 3 by 1 matrix. That is 3 rows and 1 column. So A1x, B1y, B1z, then A2x plus B2y plus C2z, A3x plus B3y plus C3z. And we know that this we can write equals to D1, D1, and D3, right? Because if two matrices are equal, then this must be equal to this must be equal to this must be equal to this. So we can say that Ax equals to B. We can write very easily, right?
Yes,
Write
sir.
this equation Ax times Ax equals to B. So from here, multiplying A inverse on both sides, we get A inverse A x equals to A inverse B. Any doubts on this?
No, sir.
No, sir.
So this becomes identity matrix I x equals to A inverse B. So x is equals to A inverse B. And what was x? X, y, and z, which we were trying to find. Is this clear, everyone?
Yes.
So whenever you see a system of equations, just use this equation and everything will be fine. No need to derive all these things. Just use this thing. X equals to A inverse B, where A is the matrix of all the coefficients of x, y, z. B is the matrix of this B1, B2, and B3. This is clear.
Sir, in this chapter, derivations will not be asked, right?
No, they will not ask you derivations, but they might ask you one or two proofs, but very less chances of that coming directly. Okay, the proofs I did in class, right? All of those, it's the better use of that is to solve similar questions. All right,
Okay, sir.
note it down. No doubts here. Anyone, Ronaldo, Wilson?
No, sir.
All right, Shikhani, are you here? No, I guess. All right, note it down.
Done, sir.
All right. Everyone done? Ronaldo also.
Yes, sir.
All right. So this is how we solve this system of linear equations. Now three cases arise from this. All right. Case one. See, we try to find A inverse to solve this type of questions. So when trying to find A inverse, we know that we have to find determinant of A. So if determinant of A is not equal to 0, then the system is consistent, having unique solution. All right. If they ask you to decide what kind of solution does the system of linear equations have, you don't have to solve everything. Just try to find determinant of A. If that is not equal to 0, then the system is consistent, having unique solution. Is this clear?
Yes, sir.
All right. In case 2, if this is equal to 0, then trying to find adjoint of A times B. If this is not equal to 0, then system is inconsistent. That is no solution. In case 3, if determinant is 0 and even this is 0, then system may be consistent or inconsistent. All right. If you face case 3 questions, just write this line: system may be consistent or inconsistent, having no solution or infinitely many solutions. Write it down. I'll explain in a detailed way. All right, just write it down. Write another line in your solution given by X equals to A inverse B. Done, everyone?
Done, sir.
All right.
Done,
So
sir.
whenever you face this type of question, just find determinant of A first. All right, check if it is solution or no solution, right? Because if there is no solution, then no point of trying to solve this. So if you face determinant of A is not equal to 0, then you have to solve this complete equation and find x, y, z. All right, that will give you one unique solution. But if determinant of A becomes 0, then you have to find this adjoint of A times B. If that is not equal to 0, then we have no solution. But if that becomes 0 also, then we cannot say. It may have many solutions or no solutions. All right.
Yes, sir.
All right, then let's solve one question. Examine the consistency of the system of equations. X plus 2y equals to 2, 2x 2x plus 3y equals to 3. All right. Let me solve the first question. All right. Here the matrix A. What will be matrix A? Anyone?
1, 2. So what is the coefficient of x?
Here this is 2,
2, 3.
2, 3. Right. Don't try to put 0, 0, 0, 0 because in the right we have only 2 variables here. So it will be 2 by 2 matrix. And x will be
XY.
xy. And finally b will be
2, 3.
2, 3. So please check the consistency. They are just asking about to examine, right? Examine. Tell us if it has any solution or not. They are not asking you to give them the solutions, right? So please try to find and tell me the answer.
So it is consistent.
Right. Having unique solution, right?
Yes, sir.
The determinant of A is 3 minus 4, that is minus 1. So unique solution. All right. No doubt here. Also, Ronaldo.
No, sir.
All right. That's all another question. Same, examine the consistency. Tell me the answer when you are done.
It is 0.
So when determinant of A is 0,
It
what do
may
we
be
try to find?
consistent or inconsistent.
No. When determinant of A is 0, then you try to find adjoint of A
Okay.
times B. Right?
Okay.
So inconsistent.
All right. So you got the answer.
Just a second, sir.
All right. Ronaldo.
Answer just a minute.
All right.
Yes, sir, I got the answer.
So this is inconsistent, right?
Yes, sir.
Yes. This is not equal to 0. So this will be an inconsistent system. All right, Ronaldo, shall we move on?
Yes, sir.
All right. So this is MCQ questions. All right. They'll ask this in 1 or maximum 2 marks. Now some good questions. Solve the system of equations. Two x plus 5y equals to 1. 3x plus 2y equals to 7. All right, this you have to solve. And solve means we have to find x and y. So this is equals to now set. Anyone solve this?
Just a minute. Done, sir.
All right, what is the answer?
So I think x is equal to 3 and y is equal to -1.
Y to minus 1. All right. Ronaldo, Kulsum, same answers? Have you solved this, Kulsum?
I got -3 and 1. Sir.
No, this is the right answer. X. Check if you have taken the adjoint the right way or not.
Yeah, I got it. Sir.
Yes, sir. So first I also got -3, but then I checked it and corrected it.
All right. No issues. So let's move ahead, right?
Yes, sir.
Am I audible now?
Yes, sir.
All right. So no need for me to solve this, right? Anyone?
No, sir.
All right. Next question. Solve the following system. Of equations by matrix method. X minus 2y plus 3z equals to 8. 2x plus y minus z is equals to 1. 4x minus 3y plus 2z equals to 4. Alright, I'll give you some time. Try to solve this. And send the answers in the chat if you can, or even speak like
Sir, last equation is equal to
4. 4x minus 3y plus 2z equals to 4. Alright, this is my z. Old habits die hard. Alright. Anyone solve this? Krishna, Kulsum, Ronaldo.
This one.
All right. Kulsum, what about you?
I'm doing it.
All right.
Sir, I got some huge numbers, sir, but I think I have made a mistake. So can you
Alright, tell
solve
me.
it?
All right. Are you getting an answer or not?
Sir, I got them, but it's not divisible by that adjoint.
Let me check. Right. I'm getting a good answer here. Okay, let's see. Here the matrix A would be 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2. And x is x, y, z. And B is 8, 1, 4. So what is determinant A here?
7.
7. Everyone is getting 7 determinant A. Ronaldo, Kusum, are you getting determinant A as 7?
I got 17.
Got 17. All right. Ronaldo,
So I got -70.
minus 70. All right. So 3 players are getting 3 unique answers. Let's see. So this is 2 minus 3 minus 1 minus 3. This is minus minus plus 2, 4 plus 2, 6 times 2 plus 12. I guess this is 3 minus 6 minus 4 minus 10 times 3 minus 30. Is this right? Or did I made any mistake? Minus 6 minus 4 minus 10. Is this right, everyone?
Sir, the second one and the third number, sir, I think it's mistake. So it's actually like 2 into 4 plus 4, right?
So minus 2 minus plus 2, 2 times 2 into 2, 4, and plus this 4. Sorry,
Yes, sir.
8. This, right?
Yes,
This
the
is
second one
16.
is 16.
Right, 16. I added 6.
Yes, and minus 6.
This is also confusing.
No, sir.
Let's see.
The last term, sir.
Last term, let's see. This is 3 times, so this is minus 6 and minus 4, minus 10, right? This is right, I guess. 2 times minus 3 is minus 6. 4, 1, 4, so minus 4. So minus 10 times 3 is minus 30.
Yes, sir. I made a mistake.
Right. All right. So this is 13 minus 17. Who was getting minus 17? I guess Ronaldo.
Sir, it's actually minus 4, minus into minus 4, sir. So it becomes plus 4, right?
No, this is 4. In the equation, we have 4 only.
No, sir, like minus 6, minus 4, like that.
No, see. This is 2 times minus 3, 6, minus 6, minus 4 into 1, 4, right? You are getting 2 negatives, but you only have to take negative ones, right?
Oh, yes, sir.
This minus this. All right. So minus 17 full sum, is this right? Full sum, is this clear?
Yes, sir.
All right. Now adjoint of A. What's what is A11? Anyone can tell me A11?
So -1.
-1. Give me a second. So, then it is. Wait. Give me a minute. Okay. All right. Still cannot write. Can you guys see one more? Everyone?
Yes, sir.
All right. So what is A11? Krishna, what
Sir.
is A11?
-1.
Minus. Are you sure? A1 and C. We'll remove this row and this column. So 2 and minus plus. Right? 2 plus 3. I guess this is 5.
So isn't that -3? It's -3.
Oh, right. Let me erase. Right. Give me a second. Let me erase that arrows. Yes, this is -3. So we'll get -1, right?
Yes, sir.
All right. So A12, what will be A12?
-8.
-8. 4 and plus 4, but -8. All right. After that, A13. So can you answer A13? Here,
Sir,
A13 means
no,
four
sir. I think
factors.
it's not -8, sir. I think it's 0.
Which one? A12.
Yes, sir.
2 times 2, 4, and minus plus. Right, this is -4. No, this is only 4. So 4 times -1, -4, but that again minus. So plus 4.
I got the answer, sir.
The final answer goes on
It's 1, 2, 3.
1,
X is 1,
2.
Y is 2, and Z is 3.
Right, absolutely right. Absolutely right answer. All right. Let's discuss. So, Kulsum, can you tell me what should I write here? A13. Factor of first row, third column, A13. And Krishna, is this right? -8. This is clear.
Yes, sir.
Ronaldo, what is A13? Are you guys still facing difficulty in figuring out cofactors?
So it's -10.
-10. Let's see. -6 and -4, -10. Absolutely right. You guys, I can solve one by one if you want. But to save time, I'm doing write this in the matrix. But if you want, we can solve individually like this. So whichever way you want. Krishna, is this okay? Can you directly adjoin?
Yes, sir.
All right. So 821. What will be 821? Anyone can answer 821?
So -5.
-5. Right? -2 into 2, -4 plus 9, 5, but negative. So minus 5. So A12
minus 6.
minus 6. Let's see. 6 minus 4 minus 6. And this one 8,
9.
2, 3, 9. Let's see. Minus 9. And this is. How are you getting 9?
Minus 9.
Minus 9. Let's see. Minus 9. And this is plus 8. Are you sure this is minus 9?
I wrote it
Ronaldo?
with 9.
Oh, yes, sir.
What is a 2, 8, 2, 3?
Sir, I got one. Yeah, one.
It's 1.
Oh,
One, right?
okay, I'm sorry, sir. I read the wrong column.
Right. So this is 1. All right. Let me check. Minus 9 plus 8. But negative sign. Right. 1. So A 3, 1
Minus 1.
minus 1. It is 2 minus 3 minus 1. Everyone minus 1, right?
Yes, sir.
Yes, sir.
So A 3, 2.
This one is 9.
This one is 9 minus 3 minus 6 minus 9. And this is minus 9. Minus 9 or plus 9?
Plus 9.
Plus 9.
Plus 9. And last one,
7.
7. 3 and plus 7. All right. And this transpose is the adjoint, right?
Yes, sir.
All right. So let's take transpose. Minus 1, minus 8, minus 10. Too many minuses here. Minus 6, 1, minus 1, minus 7. All right. This is our adjoint of A. And we have already calculated determinant of A. So final answer X will be inverse of A is 1 upon determinant A adjoint of A multiplied by, which is matrix B. Can anyone tell me how is matrix B?
814.
8, 1, 4. So this was 1 upon minus 17. This is minus 1, minus 5, minus 1, 8, minus 6, 9, minus 10, 1, 7, 8, 1, 4. This is 3 by 3. This is 3 by 1. So finally we will get only one column. So 1 by minus 17, minus 8, minus 5, minus 13, minus 4, minus 17, minus 64, minus 6, minus 17, 9, 4, 36, 34 with the negative sign. 80 minus 80 minus 79, 7 4 28.
Minus 51.
How much is it? Minus 50. Right. Is this clear, everyone? Krishna, Ronaldo?
Yes, sir.
Yes, sir.
All right. So this division is very easy. 1, 2, 3. As Kulsum said. So very good. All right. Everyone is clear?
Yes, sir.
All right. And I'm telling you again and again, don't try to find this adjoint like me. All right. And you can see even I commit mistakes when I write in a clumsy way. So please find each cofactor individually. All right. Take 2 minutes more. No one has any issues. But be accurate in the first time, in the first attempt, right? Because imagine being wrong in the examinations and you have to solve all of that again. You will waste at least 10 minutes. So take 2 minutes extra, use 12 minutes, but solve in an accurate way. All right.
Yes, sir.
Ronaldo, this is clear.
Yes, sir.
All right. Let's try another question. A matrix is equals to 1 minus 1 1, 2 1 minus 3 1 1 1. Find A inverse and hence solve the system of linear equations. Note it down the question. All right, note it down. All right, done.
Yes, sir.
So you can imagine this is a very long question, right? It feels like very long question, but this is just a like gimmick. Okay. They are asking you to find A inverse. Then they are asking you to use this to solve this system of linear equations. So there must be some way to use this information. All right. So how to use that information? Let's write this matrix. Suppose I'm calling this matrix C. This is 1, 2, 1, all the coefficients, minus 1, 1, 1, 1, minus 3, 1. All right. And X is X, Y, Z, and B is 4, 0, 4. This is clear.
Yes, sir.
So we know to solve this one, we have to write X is equals to C inverse B. This is clear, everyone.
Yes, sir.
Now what we can see, look at C and look at A. 1 minus 1, 1, 1 minus 1, 1, 2, 1 minus 3, 2, 1 minus 3, 1, 1, 1, 1, 1, 1. So we can say C is A transpose. Any doubts? Anyone? C equals to A transpose. Can I write?
Yes, sir.
Right. So I have to use C inverse here, but I know A inverse already. So remember this property. If I take inverse both sides, then I can write C inverse equals to this. I just told you in today's class. This is equals to A inverse transpose. All right. If you take A transpose inverse, that becomes A inverse transpose. Is this clear?
Yes, sir.
So you already know A inverse. Just take transpose, and that would be equal to C inverse. Use that information to find X. This is clear, everyone?
Yes, sir.
No need to solve for C inverse again. Just use this information. Also, Ronaldo, this is clear?
Yes, sir.
Yes, sir.
All right, then try to solve this one and solve this fast if possible, but accurate. All right.
Sir, can you scroll down?
Down or up?
Down, sir.
Anyone solve this? Krishna, Kulsum, Ronaldo?
No, sir. Just
All right.
done, sir.
All right. What is the answer?
Sir, I think X is 9 by 5, Y is 1, Z is 1.
9 by 5, 1, 1. But I guess Y and Z are wrong. X is right.
Is it 2 by 5 and 7 by 5?
Absolutely right. 2 by 5 and 7. These are the absolutely correct answers. Krishna, can you check what went wrong?
Yes, sir.
Check the final multiplication. Check the final multiplication. Ronaldo, what about you?
Yes, sir, I have solved it.
The same answer?
Yes, sir, correct.
All right. Do you need to solve this? Anyone, Krishna?
No, sir, I can find it.
All right, then let's move ahead. Remember these things. Like these are small things. If you follow it in examinations, then it will take a lot of time out of your hand. Right? You will find A inverse and you will find C inverse, which is very troublesome. And another type of question is, write it down. Determine the product minus 4, 4, 4, minus 7, 1, 3, 5, minus 3, minus 1, 1, minus 1, 1, 1, minus 2, minus 2, 2, 1, 3, and use this to solve the system of linear equation. X minus y plus z equals to 4. X minus 2y minus 2z equals to 9. 2x plus y plus 3z equals to 1. Alright. They're saying find the product this times this, and then use this thing to solve this thing. Alright. So you have to find the product first. So please tell me the answer of this multiplication. This multiplied by this. Alright, find the product and tell me what you are getting. Suppose this is a matrix C and this is a matrix D. Tell me what you are getting. CD. Are you guys multiplying?
Yes, sir.
Sir, I got 800, 080 and 008.
Alright, everyone getting the same answer?
Yes, sir.
So can I write this as A times I? Anyone any doubts here?
No, sir.
Alright. So can anyone see that this D matrix is equal to this A matrix? We have A matrix equals to D matrix here, right?
Yes.
Now we know that C times D is 8I. Does anyone get any hint how to find A inverse here? Because to find X, we'll use A inverse B. How we can use this thing to find this thing? Can anyone see the relation? Anyone, any guesses? Let me give you another hint. If A is equals to D, then we can say A inverse is equals to D inverse, right?
Yes, sir.
C by 8.
So how? Absolutely right. See, if I take this 8 to this side, so 1 upon 8 times C times D is equal to I. And what is the definition of inverse of matrix? If two matrices are multiplied and I get identity matrix, then one is the inverse of another. So can I say 1 by 8 times C times D is identity matrix? So inverse of D is 1 by 8 times C. Everyone, this is clear?
So can you explain again?
All right, see. If I multiply A times B and I get identity matrix, then we say A inverse is B. Right,
Yes,
Krishna?
sir.
So look at here. 1 by 8 times C multiplied by D, we get identity matrix. So if this is a matrix, suppose E, then E times D, we are getting identity matrix. So D inverse must be E matrix, or E inverse must be D matrix. Is this clear?
Yes, sir.
So we can say D inverse is E matrix. What is E matrix? 1 by 8 times C. All right.
Yes, sir.
And we know that A inverse is equals to D inverse. So instead of A inverse, we can use C by 8. All right. You all know C matrix. Just put it here, multiplied by B, and tell me the answer of X. All right. Solve this. This is clear, everyone. Ronaldo. Ronaldo, any doubts here?
No, sir. No.
All right. Solve this then. You guys have written the question, right? Everyone?
Sir, can you scroll a bit up?
Write it down. Tell me when you are done. Right. That's all. Let's write down everything. Have you solved the written the question? This part.
Yes, sir. Sir, I'm not getting the idea of the question, sir. Can you just explain again?
You are not getting what?
So the idea, sir, below, sir.
All right.
Yeah.
Let's see. Let me explain again. See, they ask you to multiply this C times D, right? And we got the 8i, right?
Yes, sir.
Now, can I take this 8 to this side?
Yes.
So what I will get? 1 by 8 times C times D is equal to I. This is clear.
Yes, sir.
And this, let's call this C by 8 as E matrix. So we know E times D is I. This is clear.
Yes.
And we know that if we multiply two matrices and we got identity matrix, then one is the inverse of another.
Yes, sir.
So can I write D inverse is E matrix?
Yes.
And E matrix is nothing but C by 8.
Yes, sir.
Now look at the question again. Can I say A matrix is equals to D matrix?
Yes.
So A inverse matrix must be equals to D inverse matrix,
Yes.
and D inverse matrix is nothing but C by 8 matrix.
Yes.
And to solve the equation x, we need A inverse times B. So instead of A inverse, we can write 1 by 8 times C matrix multiplied by B matrix.
Oh, okay, sir. Got it.
Alright, so you don't have to find A inverse in this question. You can use this relation, multiplication of two matrices, to find the inverse. Alright,
Yes, sir.
alright. Do you need to write it down or can
No,
I
sir.
go up?
Yes, I can.
Solve the equation. Alright, find the final answer. Anyone solve this?
X is 3, Y is -2, and Z is 1.
Right, I don't have the answer here. Let's match others' answer. Krishna, have you solved this?
No, sir.
Alright, Ronaldo,
Yes, sir. So x is 3, y is -2, z is -1.
-1.
Yes.
Alright,
Yes,
Kulsum,
sir,
are you
it's
getting?
-1.
Alright. Let's give Krishna 2 or 3 more minutes. Until then, you can write this question below. Ronaldo and Kulsum.
Yes, I got the answer.
Alright. Write down this question. No need to solve, just write it down. Done, everyone?
No, sir. Just a minute. Done, sir.
All right, everyone. Also, Ronaldo.
Yes,
Yes,
sir.
sir, done.
All right. So this type of question you have faced in childhood, right? बचपन के आते हैं सारे. But now we have to use matrices to find the numbers, right? If I tell you to solve this, you can solve this very easily using the childhood techniques. But the first step here also is to make the equations. All right. They are asking the sum of three numbers is 6. So let's solve. Let's say first, second, and third number be x, y, z respectively. All right. Now the first equation, sum of three numbers is 6. That means what is the equation? Anyone?
X plus y plus z is equal to 6.
X plus y plus z is equal to 6. And Kusum, can you tell me what will be the second equation? If we multiply the third number by 2 and add the first number to the result, we get 7. What should I write here?
I don't understand. Sir.
All right. Can you make the equation out of this statement? If we multiply the third number, which is the third number, z,
Z.
by 2, that means 2z, and add the first number to the result. That means this result is added by x. We get
Okay.
7.
Okay.
All right. That means we get 2 plus 7. So this is the second equation. All right. So try to tell me the third equation from the third statement. This one.
3x plus y plus 2z.
2z. Are you
Z.
sure?
Z
Z.
is equal to 2.
Absolutely right. So these are the three equations. So using these three equations, we can find x, y, and z. Any doubts, anyone?
No, sir.
And we can all solve this three equations very easily, I hope, or not.
Yes, sir.
All right, Wilson, Ronaldo.
Yes, sir.
Okay, so this solving these three equations is your homework. We are almost out of time. All right, this is your homework. In the next class, I will ask you about x, y, and z. You have to tell me. All right, and the chapter is finished. So complete the NCRT exemplar, and assignments. All right, in the next class. In the next class, we are going to start relations and functions. All right, everyone.
Okay, sir.
Okay, sir.
So any doubts from this chapter, matrices and determinant? Anything that you need to understand again or anything like that?